So, so everybody can see it. So now, my topic is today science behind beta thalassemia. And I will take 20-25 minutes to discuss about science behind thalassemia. My main focus is to focus on the challenges and to also to tell about the solution as well. So I have made C7 to S7. C7 means 7 challenges to S7 solution. And after this, I will go through the treatment of luspatercept, its pivotal trial, belief trial, how they use it, and finally how we use in our setup as well, dosing and administration, and finally take-home message. So you have seen the ribbon of beta thalassemia more often. So this is just for awareness. So this is the actually ribbon, and the World Thalassemia Day when is observed. Everybody know it is 8 May is observed. And now, question 3 is what is the goal of therapy in beta thalassemia major? Beta thalassemia major is chronic disease. The thing is, we have to find out is there any cure, and if not cure, then you have to control wisely to make sure the continuity of the quality of life, and you have to care all the organs, especially liver, heart, and pancreas and bones, and of course the combo of treatment and clinical trials. So first 3 things I will go now: challenges and their solution. So beta thalassemia is highly burdened over all the world. You can see 90 million people, about 1.5% globally, they are carrier of beta thalassemia, and 60,000 affected individuals born annually. It starts from east and migrate from the west as well. So you can see all the regions are affected. Improved survival, if you go from 1970s, the median survival was just 17 years. Then each decade it go to 10 years, 27, then 37, and now more than 2000 it goes more than 40,000. So thalassemia journey till today is encouraging. If you go by some words of Winston Churchill, he says that the longer you look and back, the further you can look forward. And more encouraging, as Mr. Volko says 2 centuries ago, I don't wish by any means to infer the disease in questions which is incurable, like thalassemia major most of the people, and I hope the contrary, that too many remedies will come that will be discovered. So we have seen a century ago beta thalassemia was diagnosed by Cooley's clinical, and then first time transfusion in 1946. Then they have seen the organs are affected. Then allogeneic transplant came, then MRI to screen the overload, and then iron chelating agent, then gene therapy, and currently we are era of novel therapy. Now, do these things will impact we win the match in 2022? You can see if you don't treat thalassemia, unfortunately, the survival is 2 to 5 years. But if you go from fourth period, like this one, if you go from here, first period, before 1960, it was a dismal prognosis. This is the first, blue curve. When transfusion came, it increased. Then iron chelation agent, it's a huge difference. And finally, new iron chelating agent and the new therapies for heart, liver, and other things, they impact this one. But over the 2 decades now, it is stable encounter. So new therapies we need, and which we discussed today. So challenge 2 is there that we know beta thalassemia is an inherited disease. The problem is continuously hemolyzing and ineffective erythropoiesis. And we know that especially beta thalassemia major, they require continuous some treatment, otherwise it's difficult to survive. The first thing which came in 1960s, as I mentioned, to transfuse the blood who are transfusion dependent. The rationale for RBC transfusion in beta thalassemia is to supply sufficient red blood cell to suppress ineffective erythropoiesis and associated morbidity. So you can say it was just to salvage, to save the person, to give RBC, to suppress infective erythropoiesis and morbidity. but this is not actually solution. Why? Because the challenge is there when you transfuse RBC, you have come across four issues. Number one is logistic issue, of course, administration and travel, increased risk of infection, and aluminization. And the most important thing is iron overload, which increase the risk of organ dysfunction, including heart failure. So these are the complications of transfusion. Everybody know it affects mostly liver and heart actually. So that's why more focus on this. Number third, more effective organ is the all endocrine and the bones, and this is how the patient go with cardiac, hepatic, and endocrine abnormalities. So current management, a decade ago, regular transfusion, iron chelation, and monitor the complication, manage the complication, and if you have matching, then patient can go for stem cell transplantation. Now, there is some unmet. Challenge 4 is unmet. Why unmet? I would say because, as I mentioned, you are suppressing, infective erythropoiesis, just giving transfusion at the cost of such a huge complication, which I mentioned. So it means this can reduce if you target properly infective erythropoiesis, giving something which target the infective erythropoiesis, that will decrease blood transfusion load, that will decrease the iron overload, and that will decrease all the organ complications. However, so far a decade ago, therapy advanced, improved safety of the blood supply, reduced incidence of aluminization, very good oral iron chelation, three types are there, improved monitoring of iron overload there, improved treatment of hepatitis, and improved outcome of stem cell transplantation. There is area of improvement. What is area of improvement? Because, as I mentioned, current therapy is limited to RBC transfusion and iron chelating agent, which don't address actually properly infective erythropoiesis. This led me a complication that is thalassemia is benign or malignant disease. I would say it is neither benign nor malignant disease. It is more complex disease. How? Now, just bit go background of the basic normal erythropoiesis is two steps actually. Number one step is proliferation of the cells, which is performed by the EPO. And second is differentiation of erythroblast to mature RBC, which is regulated by TGF-beta ligands. Now, what happens in more in beta than alpha thalassemia in ineffective erythropoiesis? Just understand the basic mechanism. What happened there in beta thalassemia? It is expansion of early erythroid precursor. What happened because of this? Because of this, accelerated differentiation happened and maturation arrest and apoptosis. This is all because this all cause accumulation of TGF beta ligands. So the culprit is TGF beta ligands. If you fix it, then things will be convert from ineffective to effective erythropoiesis. What caused ineffective erythropoiesis? Sorry, busy slides. It caused extramedullary and intramedullary problem. Extramedullary, you have known extramedullary hematopoiesis like hepatomegaly and spinal nerve compression, and expansion of the bone marrow that lead to the bone disease, skull changes, and osteopenia fracture. And intramedullary cause premature erythroid precursor death, which cause damage of hemolysis. All of these things need RBC transfusion, and then iron overload, endocrine, and heart and liver disease. So now we are focusing in ineffective erythropoiesis. So where there is a will, there is a way. So there are four options you can do it. Number one is, if you don't allogenic transplant, you can focus on gene therapy. And more important, which we is topic of today, ineffective erythropoiesis, you have now four treatment: JAK2 inhibitor, luspatercept, PK activator, PTK9 inhibitor. We'll focus on this. And other thing is you can also hold the hemolysis, and you can also decrease the alpha gene synthesis as well. So first thing is a solution. JAK2 inhibitor was tried in truth trial, ruxolitinib, in transfusion-dependent thalassemia. They reduced the spleen volume, but they did not reduce the RBC transfusion. So this is the failure trial. Second solution is you can use luspatercept, which is actually, what is this luspatercept? Is recombinant furan protein. So this is the structure of the recombinant furan protein. What you can say is like Caesar, this is the yellow color is, TGF, which is sitting there causing ineffective erythropoiesis. So luspatercept go there and remove this TGF superfamily, and that cause ineffective to effective erythropoiesis. So first it was done an animal study, then phase 1 study, then phase 2, and now we are talking phase 3 study. We'll talk a little bit. So the theoretically, if luspatercept blocks the TGF beta ligase, it will promote the RBC differentiation and maturation. Here you can appreciate after proliferation and differentiation, it become maturation. Now it become normalized. So what will happen? Theoretically, if and this was the unmet need before, we didn't have ineffective anything to suppress the infective erythropoiesis. But if luspatercept really it cause it can convert more effective erythropoiesis, reduce the extramedullary hematopoiesis, and improve the hemoglobin level. You don't need more transfusion. You don't need to keep the patient risk on the transfusion, which we discussed before. And sixth challenge is stem cell transplantation. No doubt stem cell transplantation is curable, but the problem is matching is also problem. And also, allogeneic transplant is not easy without any complications. But currently they are finding some gene therapy. What they do, they take out CD34 stem cell from the patient. It goes through by the beta gene with the vector. They transduce it and they make it convert it, become normalized, and the patient goes through the myeloablation therapy and then they are infused. So this is how gene therapy. So what is the difference between allogeneic transplant and gene therapy? In both, the chemotherapy is used, but the gene therapy, the good thing is not use immunosuppressive therapy, so there is no graft versus host disease. Gene therapy is equivalent to autologous transplant. The problem is it is new one. We don't know the long-term side effects. So now we are in 2022. What is the transfusion dependent treatment? Number 1, blood transfusion. Number 2, luspatercept. Number 3 is iron chelation to monitor the iron. And number 4, to keep an eye on the complication by MRI, endocrine of the bone. And number 5 is the stem cell transplantation. This is the high-five of 2022. But important thing is, despite of all these, as we mentioned, beta thalassemia necessitates the multidisciplinary approach management. No doubt, thalassemia physician is the center, but they needs all nurse specialists from GI specialists, diabetic, endocrine, reproductive, cardio, transplant specialists, psychiatrists. So you need everybody. So all solution is there. So you have noticed the last few minutes I spoke the solutions. All these solutions, 7 challenges and 7 solutions. Now thing is how to translate into the reality. So I have there 7 steps to expert online using NCCN and CCO. So this is expert online. You put the data. I put for one of my patients, they will ask you 7 questions. One question is, it is transfusion dependent. Second question is, it is related to any complication to anemia, allo antibodies, and what about the iron? Is there eligibility of transplant? In this patient, I have the problem with the transfusion. I have the problem with the maintaining the iron overload. So what they recommended, you appreciate everybody accepted luspatercept as the choice here, 1, 2, 3, 4, almost 100% people say 8 the luspatercept. And there is another patient transfusion dependent, in which also the patient even stable, but the problem is the iron balance is the problem. Again, out of 4 experts, 3 experts, they recommended go for luspatercept, and 1 say to intensify the iron chelation agent. So this is how, now we are talking about what is the luspatercept, why everybody is talking luspatercept, it is what is the really from bench to bed, anything is a good thing they are saying. So as I mentioned, this is recombinant furan protein. They remove the beta-2 ligand, which we had already discussed. It is approved in 18 years of the age in all genotypes and RBC transfusion dependent. So this is the BELIEVE trial, which is actually phase 3 trial. And this is on the thalassemia major patient. It is more than about 400 patients. It's 2 to 1 randomized trial. And the primary endpoint was to check 33% reduction of RBC transfusion burden after giving the luspatercept. So we'll see. And they choose actually heavily treated, highly dependent on blood transfusion, very frequent blood transfusion dependent. More important here, you can see splenectomy was done about 60% of the patient. So let's see what is the efficacy. Efficacy, as I mentioned, the primary endpoint of luspatercept, which was, what was the target? Target was reduction in 33% transfusion within 3 months, and they achieved this thing within the 12 weeks of the period. So first target received, and then second target was deep reduction in RBC transfusion. That was 50% transfusion reduction over the fixed 12 weeks period that also received. So now you can see the transfusion requirement is much less as compared to the placebo arm. And similarly here, so if you reduce the transfusion, it means you reduce the iron overload, reduce the infection without any saying, you know all about this. So luspatercept actually increased the hemoglobin within 7 days, and within the 9 months, actually almost everybody is responding. So now the iron, naturally, you can see this is the luspatercept. The iron is minus 23.3. It means it impacts naturally iron overload as well. So what is the safety profile? The safety profile, it causes musculoskeletal side effect, and some patients it causes hypertension, and 2% patient thromboembolism. So this is how you go. The important thing is it is not recommended in the pregnancy and patients who are hypersensitivity. Otherwise, there is no so far any black box warning. So it's going very safely so far currently. Just you have to see any patient who has history of thromboembolism or increased blood pressure. On these things, patient you have to care. Otherwise, there is no issue with this. How to administer this patient? You have to start with a 1 milligram per kilo subcutaneously upper arm, thigh, or abdomen every 3 weeks, and you have to monitor hemoglobin level and grade 3 toxicity, and you can go up and down like over the 6 weeks. If patient is going, response is good, you don't have to touch it. If the response is low, you can increase to 1.25 milligram, and this is how you increase the dose. And how to reduce the dose? If you reach 2 gram of the hemoglobin within 3 weeks, you have to reduce the dose. If your patient is 1.25 milligram per kilo, you make it 1 milligram. If your patient is 1 milligram, you have to reduce the 0.8 milligram per kilo. So this is the presentation of luspatercept. You have the vial of 25 milligram and 75 milligram. So what you have seen in the BELIEVE trial, we have seen that they made the primary endpoint, which is 33% reduction in RBC, and reached the secondary point, which is 50% reduction of the RBC transfusion as well. And there is was generally well tolerated. The musculoskeletal is the important side effect. Otherwise, 2% VT is also no. Luspatercept approved in the FDA in 3 years ago, and EMA last year. So it is, we are also using in the UAE as well. So now in next 3 minutes, I will go one case again. This is my 34-year patient who is transfusion dependent, who has complex medical history actually, and transfusion dependent at the age of 1 year with the deproximant sub-Q every 3 years, and then it was shifted to the XJ at age of 20. However, he lost so many organs, cardiac, diabetes, and also other problem as well. He refused for he has splenomegaly, but refused splenectomy. So what is the expert online say for these patients? You can say 100% experts say all of three, that patient should get luspatercept. So we have started luspatercept this patient. Now, in summary, last 20-25 minutes, what I wanted to emphasize the science behind thalassemia management. I went through the eye-opener questions to showing to the ribbon and the World Thalassemia Day. Then I went to C7 to C8, means 7 challenges and 7 solutions. I used the resources to solve the challenges. That resources, as I mentioned, NCCN guideline and CCO guideline, expert online. You just put in the Google CCO expert online. You put your patient data. It will tell you how you manage your thalassemia patient. And most importantly, I presented BELIEVE trial, which is more than about 400 patients, let's participate, and which has indicated the very good efficacy, 50% reduction of the transfusion with a good safety, and the dosing administration I mentioned clearly. So this is my final, take which I'm giving to you. So please put your questions in box. We will able to give you answer all the question happily. Thank you very much.